Welcome to my YouTube channel JK Mathematics Classes. Today I will discuss Class 9 Maths Chapter 8 Quadrilaterals Exercise 8.2 question number 5. So question number 5, given in parallelogram ABCD, E and F are the midpoints of side AB and CD. To show line segment AF and EC trisect BD, that means AF and EC divides DB into three equal parts. That means this part, and this part are equal. That means DP equal to PQ equal to QB. Solution. So here we use the converse of, to prove this, we use the converse of midpoint theorem. So we take the triangle ABP and triangle CDQ. So triangle CDQ. For triangle ABP, so we need a parallel lines. To get a parallel lines AF and EC, so first we show AECF is a parallelogram. So AECF quadrilateral is a parallelogram if each one pair of opposite side is parallel and equal. That means AE equal to CF and also AE parallel CF. So here E is the midpoint of AB. E is the midpoint of AB. That means AE equal to, so here AE equal to half of AB. This is equation number 1. And F is the midpoint of CD. F is the midpoint of CD. So we get CF equal to half of CD. Again, half of CD, in place of CD we put AB. So since AB equal to CD, opposite side of parallelogram, ABCD. So this is equation number 2. From 1 and 2 we get, from 1 and 2 we get, so here A equal to half of AB and CF also half of AB. So both equation having right side equal, so A equal to CF, and AE parallel CF as AB parallel CD. So opposite side of parallelogram ABCD. So AECF is a parallelogram. ABCD is a parallelogram. So in parallelogram AECF, so their opposite sides are equal. So AF and EC are the opposite side of parallelogram AECF. So AF parallel to EC. That means opposite side of parallelogram AECF. So here AF parallel EC. So we take the triangle. So in triangle ABP, so here E is the midpoint of AB. E is the midpoint of AB. that is given. And here EQ parallel AP. So EQ parallel AP as AF parallel EC. So if two sides are parallel, then their parts are also parallel. So AF and EQ are the parts of AF and EC. So AP parallel to EQ. So in triangle ABP, so E is the midpoint of AB and EQ parallel AP. So by converse of midpoint theorem. So by converse of midpoint theorem, if a line is drawn one side, midpoint of one side is parallel to another side, then it will bisect the third side. So if a triangle, suppose ABC, in triangle ABC, if a line is drawn through a midpoint of any one side is parallel to another side, then bisect the third side. That means bisect means AF equal to FC. So F is the midpoint of AC. So by converse of midpoint theorem in triangle ABP, so E is the midpoint of AB and EQ. So EQ is a line or side through a midpoint of AB, and it is parallel to AP, that means another side, and bisect the third side, that means Q is the midpoint of PB. So by converse of midpoint theorem, so Q is the midpoint of PB. So that is, midpoint means PQ equal to QB. PQ equals to BQ or QB. So this is equation number 3. And also in triangle, so first triangle is this ABP, and in triangle CDQ, so here F is the midpoint of CD, and FP parallel to CQ. So CQ is the base, so FP parallel CQ as AF parallel EC. So here FP, if a line is drawn, so converse of midpoint theorem is if a line is drawn through the midpoint of one side is parallel to another side, then it will bisect the third side. That means midpoint. So F is the midpoint of CD. So by converse of midpoint theorem, so here P is the midpoint of DQ. So P is the midpoint of DQ. That is, P is the midpoint of DQ means DP equals to PQ. So this is equation number 4. From 3 and 4 we get, so PQ equal to BQ, again also DP equal to PQ, so all are equal. So DP equals to PQ equals to BQ. So hence proved, hence shown. So today class is finished.